All right, so you've drawn these on the back, yeah? This is called a proportion. We're going to set up a proportion or proportions today, just like we did yesterday. How do we solve a proportion? What do we do to solve a proportion? Cross multiply. So that's what we're going to do. Multiply across the equal sign 5 times 3, which is 15. Then the other way, 9 times x. 9x. How you doing, Brady? And then the last step is to divide by 9. I do want us to practice reducing because it's important. So what are 15 and 9 both divisible by? 3. 15 divided by 3 is 5, and 9 divided by 3 is. So we're going to leave it like that because there are a lot of fractions in this section with scale factor and whatnot. The second, we will do the same thing. We have n to solve for. What is 2n times 3? 6n. And then 11 times 4, 44. Divide by 6. What are 44 and 6 both divisible by? 2. What is 44 divided by 2? 22. And then 6 divided by 2, 3. Perfect. Questions about proportions? Wonderful news. I believe we're on the bottom of page 3. You will find this. Reminder about your supply check. What day of the week is it next week? Tuesday. It's just over the supplies that you already have, Addison, hopefully. I listed them over there. Mainly pencil, red pen, colored pencils, an eraser for your whiteboard, paper, and then if you see a star next to a calculator, I'm going to tell you, you will not pass without a calculator with your name on it. So that's why that star is there. It's super important. You have a quiz the same day and a test on Thursday. So that's next week for you to know. So this is on the bottom of page 3. We talked about similar figures yesterday. Can someone explain to me what a similar figure is? I'm looking for something in particular, but not reading from your notes. Yes. It's when corresponding sides are proportional. I'll take it. So there are two things. The sides are proportional, but what do we know about the angles? They're congruent. And then what do the shapes look like in general? They're the same shape. Yeah. Same shape, but they are proportional in size, similar to this one. So these are check boxes if you have ever, I don't know, the way that I think, I always go through like check, check. Corresponding angles are going to need to be congruent. So that is your first blank. Corresponding angles need to be congruent to have similar figures. And then the corresponding sides, just like she said, they have to be proportional. They have to be proportional. And in order for them to be proportional, they have to have the same something. Scale factor. There is definitely not enough room in these blanks, and I am so sorry. So that's that. So use this like a checklist to figure out if things are similar or not. Are the corresponding angles congruent? Check. Are the corresponding sides congruent? Check. And then that means they are similar. So looking at this shape, are the corresponding angles congruent? Yes. What does A correspond with? E, and they both have 2 arcs, so they're congruent. B corresponds with F, and they are congruent. C corresponds with G, and they're congruent, so on and so forth. So the corresponding angles are congruent. Then you want to figure out if the sides are proportional. This is probably really easy to see if they are. Do they have the same scale factor? Yes. What was each side multiplied by? 2. 6 times 2 is 12. 2 times 2 is 4, so on and so forth. So yes and yes, the scale factor was 2. So that means that these two shapes are similar. And then another thing we learned about yesterday was how to write a similarity statement. So you name the first, you write this squiggle. What does this squiggle stand for? Similar. So CBAD is similar to, and then the order of the letters of the second. C came first. What does C correspond with? G. Oop, yep, G. B is second, which corresponds with F. And then you have A, which corresponds with E. And then that means H is last. Ta-da! You can go to the next page. Oh, sorry. We're actually going to go to the whiteboard first to see if you remember. So some of you don't have whiteboards yet. I'm going to work on that right now. Put on your whiteboard. You're going to decide if they are similar. If they are, you're going to tell me the scale factor. And then the statement of similarity. Or the similarity statement. Everyone else have one? If they are not similar, you just explain why they are not similar. It's good, you just need to do all the sides, and then you're going to write a statement if you think. Good. I don't know what you wrote. We read left to right. So then the right will be if it's not written. Okay, I see some are struggling. To find the scale factor, what did I tell you was like the shortcut to find the scale factor? Yeah, put the new length over the old length. So we could start with 24. What does 24 correspond with? 15. It's okay. So what is the new length? 15. And the old length, what does that reduce to? 5/8. Okay, pick another side. We have 32. What does 32 correspond with? 20. So the new length is 20. The old length is 32. This reduces to 5/8. And then the last side is 40 and 25. The new length is 25. And the old length is 40. This reduces to 5/8. So are the sides proportional? Yes. Are the corresponding angles congruent? Is there an angle congruent matching in each of them? Yeah, 35, 35, 55, 55, and then right angles. So are these two triangles similar? Yes. So you'd write a similarity statement. How would you like to name the first triangle? ABC. And then is similar to triangle. We said A first, which corresponds with X. We said B second, which corresponds with Y, and then Z. And then your scale factor was 5/8. Is 5/8 the same scale factor as 8/5? So we went to a smaller shape. Your scale factor needs to be less than 1. Do you have a question on this one? going to go back to our notes and find this section. Well, when you turn to the next page, it's on page 4. We already did the first question here. We're just going to do the second. Just find the length of km. So nothing is written for km. We can call it x if we would like. I would prefer to. So again, what do we know about the sides in similar shapes? They're proportional. So we're going to set up a proportion. So I'm going to start with x because I prefer to. So x over, what does x correspond with in the second shape? HF, which is 35. And we're going to set it equal to the ratio of the other sides. So here's a reminder. The top row should be from the same shape as should the bottom. So reminder there. And then like one fraction should be corresponding sides. So x correspond with 35. So for the second fraction, what is on the same shape or on the same triangle as x? 48. And then we need what corresponds with 48 to go in the denominator, which would be 40. Right, 40? All right, so we have one fraction set equal to another. We are going to cross multiply. So x times 40 is 40x. And then 35 times 48. What is it? 1,680. Sounds good. Divide by 40. X is 42. I believe we're going to go back to our whiteboards here for you to practice. The polygons are similar. Find the value of x. So if they're similar, the sides are proportional. You're going to set up a proportion. We're going to go back to the notes. So these need to be corresponding, and across need to be from the same shape. So these are fine. These correspond and these correspond, but are these two from the same shape, and are these two from the same shape? So that's where I would fix one of them. You don't have to erase all of it, just one of the fractions. Right. Let's go. It doesn't matter. You're making a proportion. That's good. Just rewrite it. That was it. It happens. That's good, and that's good, right? Pretty sure. Yeah. Sorry. There's a lot of slides. You gotta set up a report. That's good. Good so far. You just gotta multiply those two. All right, so for the first, pick a side, any side. Sounds good. X, what does X correspond with? 7. So remember, each fraction has to correspond with each other. And then when you go to write your second fraction, remember the top have to be from the same shape. So what is the only option to go on in the numerator of the second fraction? 2. And then on the bottom, corresponding with 2 is 3. So remember, top and bottom have to be corresponding. A cross has to be from the same shape. You would cross multiply. You end up with 14 over 3. The second, we want to solve for x. So just make sure you incorporate x at some point, but we are going to do the same thing. Set up a proportion because the sides are proportional. So what side do we want to pick first? That's fine. X, which corresponds with 25. So the most common mistake I see people do is they put x in the numerator. I'm just going to put num because why not? And then they don't pick from the same shape to go in the second numerator. And then they get it wrong. So remember that the top row has to be from the same shape, and the bottom row has to be from the same shape as well. So you can either pick 8 or 12. There is not a wrong answer here. So you just have to pick 8 or 12. Which one? 8 sounds good. And then 8 over, what does 8 correspond with on the second triangle? 20. Okay, and then you would cross multiply, and you end up with 10, right? 10. Okay, you can erase it for now. We're going to talk about perimeter and area, and then that's the end of 8.1. I would say 8.1 is 50% of the whole chapter. The other lessons are super short. This one was super long. It has a lot of concepts, but it kind of gears you up for the rest of the chapter. So we're going to talk about perimeters, similar shapes and then perimeters. So if you look, there's a box in the top right of page 5. We're on page 5 now. Go ahead and highlight that box. We're going to fill it in with the formula you use to find perimeter of similar shapes. And here's where the formula comes from. The ratio of the perimeters is equal to the ratio of the corresponding side lengths. So the ratio of the perimeters is equal to the ratio of the side lengths. What the heck does that mean, Ms. Marshall? Let's show you. I'm going to use these two shapes. They're similar to each other. I'm going to say this is 1, 2, 3, and 4. Like, this is 1 centimeter and 2 centimeters, 3 centimeters. And then let's say our scale factor, we'll make it easy, and we'll make it 2. So what would the length of PS be? It'd be what? 2. What would the length of PQ be? 4. What would the length of QR be? And the length of SR would be 8. Okay, so let's look at their perimeters. All right, let's look at their perimeters. How do you find the perimeter of any shape? You add the sides. So let's start with this. 1 plus 2 is, plus 3 is, plus 4 is. Okay? 2 plus 4 is 6, plus 6 is, plus 8 is 20. According to this, the perimeters have the same ratio, the same scale factor as the side lengths. Now let's take a look at that. What was the scale factor for the side lengths? 2. All the sides were multiplied times 2 to get the new side lengths. What's the ratio of the perimeters? Still 2, right? 10 times 2 is 20. So here's what's going to happen, and the formula is going to come from. When I hit next, it'll go away, but I will put it back. You're going to take a side from the first, put it over a side from the second, and it will equal, those ratios will be equal to the perimeter of the first over the perimeter of the second. And I'll show you with our example here. But this is what goes in the box. I'll also show you how I shorten it, because ain't nobody got time to write that for every problem. But aside from the first over aside from the second equals the perimeter of the first over the perimeter of the second. So I'll show you what that means. Pick a side from the first shape. Doesn't really matter which one you call the first shape. I usually read left to right. Just pick a side, any side. 3, sounds good. So I'll put 3, I'm going to write here, in the numerator as a side for my first. What is the corresponding side? It has to be the corresponding side from the second shape. 6. It is saying that these two sides, the ratio of them, is equal to the ratio of the perimeters. What is the perimeter of the first? 10 over the perimeter of the second, which is 20. Now, are these two equivalent to each other? What is 3 over 6 reduced to? 1/2. I don't have room to write that, but 1/2. And 10 over 20 reduces to 1/2. So are the ratios equivalent? Yes. That's where this formula comes from. It doesn't poof out of anywhere. Some people don't like to learn the formula, but we use this formula for area and for volume. So there's not a way to do it in your head for area or volume other than to use the formula. So I would learn it now just so you know it later. So that's just me. But we're going to use it here with this gazebo question. These two gazebos shown are similar pentagons. Find the perimeter of gazebo A. When I write the formula, I write S1 and S2 representing a side from the first and a side from the second. It is much less to write. And it is equal to the perimeter of the first over the perimeter of the second. Is everyone okay with the formula? This is just the shortened version instead of writing all those words. So, there is a way to do it without the formula. In this case, you could find all of the lengths using proportions, and then you can add all of the lengths. It is much easier just to do the dumb formula. And again, later on, you will have to use the formula for area. So, in any equation, how many missing parts should we have? In any equation in general, how many missing pieces do we want? Just one. So our goal is to have one missing piece. What is the only thing we care to find? In this picture specifically, the perimeter of gazebo A. Okay, we'll say A is the first shape, whatever. So we are missing the perimeter of the first shape, gazebo A. That is the only part that should be X or P. I'm going to call it P for perimeter. Okay, everything else should be filled in. So here's how we're going to do that. We don't know the perimeter of gazebo A. I'm going to write P, you can write X, it doesn't really matter. Everything else we will know. So for a side from the first, what is the only side we know in the first shape? 10. So 10 will go in the numerator. And aside from the second, it has to correspond with the side we picked from the first. So that has to be 15. So aside from the first over aside from the second equals the perimeter of the first, which we don't know, and then the perimeter of the second we don't technically know, but we have enough information to figure out. How do we find the perimeter of any shape? Add all the sides. I think the easiest way is to, what's 15 plus 15? 30. 18 plus 20, plus 12 is 30, and then plus 9 is 69. So the perimeter is 69 of the second shape. Are we okay with our perimeter? Great. So then how do we solve a proportion? Cross multiply. 10 times 69 is 690 equals 15 times the perimeter that's missing. Divide by 15. What is 690 divided by 15? 46, and this would be meters. We can recap here for a second. Could I have picked any other numbers besides 10 and 15 in this case? I could not have. I need corresponding sides, and the only side I was given was 10 in the first, so the only side I could use in the second is 15. So they have to be corresponding in order for this formula to work. So you would have had to have found a different side to use different numbers. All right, so on your whiteboard, I first want you to set up, write down the formula, and then plug in where you think everything should go. And then I will tell you you're correct, and you can move on. So go ahead and write the formula, plug in everything you know and don't know, and I'll come around and look at it. I don't think that times that is that. See how there's 5 digits? It should be maybe 5, maybe 4. So then that would be 0. So it has to be side over side, perimeter over perimeter. So this is saying that these two have to be from the same shape and these two have to be from the same shape. So you're saying the side you're missing is from the figure A. Good. All right, so you have a side from the first over side from the second equals perimeter of the first over the perimeter of the second. Do we know the side from the first shape? We do, and it is 18. Do we know the side from the second shape? We do not. And then you could put S, some of you did. And then the perimeter from the first shape, 72. And then the perimeter of the second shape is 120. Cross multiply, we end up with X or S, but that remaining side is 30 meters. 30 meters. Which makes sense. Here's why you want to think through your answers. Do you see how the smaller numbers are in the top? We see? And then the bigger numbers are in the bottom. That's because in a proportion, we're literally saying that this fraction is equal to this one. So they have to have like the same pattern. I'll show you why that matters here. Go ahead and go back to your notes really quick. Two polygons are similar. The perimeter of one polygon and the ratio of the corresponding side lengths are given. Find the perimeter of the other polygon. So you're still using side 1 over side 2 equals perimeter 1 over perimeter 2. Here's the thing, though. They already gave you the ratio of the corresponding side lengths. What you need to do is plug in the perimeter in the correct place. So what is the ratio in our first one of our corresponding side lengths? It's called scale factor. 3/4. And it's equal to the perimeter of one of them over the perimeter of the second one. We don't know which one's first or second, but here's what I do know. This is the perimeter of the smaller shape, correct? Remember what I just said 2 seconds ago. We're saying two fractions are equal to each other. So you see how 3/4, the smaller numbers on top and the bigger numbers on the bottom. So our smaller number should go in the numerator in this case, and the bigger number should go in the denominator in order to make it match. Everyone follow that logic. So 12 is the smaller polygon. We do not know the perimeter of the larger polygon. You put X, you put P, it doesn't matter. This is just option 1. Cross multiply, and we get 3x equals 4 times 12 is 48. Divide by 3, which means the larger polygon has a perimeter of 16 feet. Is that larger than the perimeter of the smaller polygon? Yes. So you need to think through your answer. If you got a smaller number, you put the perimeter in the wrong place. This is option 1. Option 2, if you like fractions, wonderful. What does a scale factor do in any case? Is it add, subtract, multiply, or divide? Multiplies. So technically you have two shapes, and the scale factor is 3/4. The perimeter of the smaller one is 12. You could use the scale factor to find the perimeter of the larger. But you need to be careful when you do that, because if I were to multiply 12 times 3/4, is that the scale factor from the smaller to the larger? It is not. That's the scale factor from the larger to the smaller. So what would the scale factor from the smaller to the larger be? It wouldn't be 3/4, it would be 4/3. It'd be the reciprocal. So this is option 2. But again, you need to keep track of what your scale factor is. Is everyone okay with remembering scale factor? If it goes from a smaller to a bigger, it needs to be bigger than 1. If it goes from a bigger to a smaller, it needs to be smaller than 1. Which one do you see yourself more so using? This one you just have to be good at fractions. Do you see yourself using option 1 or option 2? Option 1. Okay, that's fine. All right. The second, we have the perimeter of the larger polygon and a scale factor. Again, our scale factor is 6/5. We're going to use that to find the perimeter. So where am I going to put 72? It's the larger polygon. Is it going to go in the numerator or the denominator? Needs to go across from the larger, so the numerator. Cross multiply, 6 times x is 6x, and then 5 times 72, is it 360? It is. Divide by 6, and x is, yes, 60 inches. Which, again, this is why you have to think through it a little bit. So our answer that we got was 60. If we reduced 72 over 60, guess what it reduces to? 6/5, which is what it's supposed to. Questions on this section? Okay. We will come back to this in a second. We're going to finish with area. So remember how I said area is the same formula as perimeter? There's one thing that's different. So go ahead and highlight, again, that box in the top right corner. Right there. Oh, sorry. All right, and then you're going to fill it in. It's the same formula except for what is the difference that you see? Well, area, and then what else? The sides are squared. So same type formula, except for you're obviously using area, but the sides are being squared. Is the only difference. So aside from the first over aside from the second, squared equals the area of the first over the area of the second. So guess what volume is? is cubed. The same formula, but cubed. That's why it's just best to learn it now, so that later on, you know what you're doing with your life. So, we're going to use it here. Because we know we have similar shapes, what it says, find the area of LMNP. So, we don't have enough to do length times width. That's why we're doing this right now. We're going to take a side from the first, over a side from the second, squared. It equals the area of the first over the area of the second. So what is a side from the first shape? 7. And then that corresponding side on the second shape, 21. Equals the area of the first, which is 84, over the area of the second, which is what we're trying to find out. You could put A, you could put X, it doesn't really matter. So this brings us to squaring a fraction. What are you doing when you square something? Are you multiplying it times 2? No, you're multiplying it times itself. So I'll show you the shortcut. You're technically multiplying 7 over 21 times 7 over 21. It's equivalent to squaring the numerator and squaring the denominator. Does everyone see how? 7 times 7 is the same as 7 squared. 21 times 21, because you would multiply straight across, is the same as 21 squared. So when you do this, you're going to square the top and square the bottom. Yes, ma'am? You can, but I'm going to show you this way first, because I'm recording, and some people are not great at reducing. But good question. She asked if you can reduce. You can, and I'll show you that second. And we can choose which one we'd like to do. All right, so 7 squared is 49. So you square the top and you square the bottom. 21 squared is 441. Don't ask me why I know, I just do. So we squared the top and we squared the bottom. Is everyone okay with 49 over 441? Okay. We will then cross multiply. So we got 49a equals a very large number. What is 441 times 84? 37,044? Yes. Perfect. Divide by 49. 756. And it would be meters squared. Perfect. So your ex has asked a great question. Can we reduce? Yes. And if you are good at reducing, I would recommend it. But I asked my first hour if they would like to reduce, and they said yes, it reduces to 3. And they would have gotten the answer wrong. So if you're not good at reducing, I would not reduce. If you are good at reducing, what does, so I'm going to leave the right side alone. I rewrote it, but I left the right side alone. If we wanted to reduce before we squared, what does 7 over 21 reduce to? 1/3. Also a reason I prefer to show you both ways first. You still square the top and you square the bottom. A lot of people think that you don't when I write it this way, because what is 1 squared? 1. So it looks like we didn't do anything to the numerator, but we did. And then what's 3 squared? 9. So then cross multiply, you get the area equals, and then 9 times 84 is 756. So you get the same answer, but again, if you are not good at reducing, I would not. If you are good at reducing, then do it. How do we feel about it? Good. Yes, you are honors. All right, find the, man, these are the same. I wanted a different one. Hold on, RST. We'll do that one in a second. Find the area of triangle DEF. We'll practice with, we'll see what you want to do. But anyways, side 1 over side 2 squared equals the area of the first over the area of the second. So So same formula. What is the side we're given on the first shape? 10. And then the side we're given on the second shape? 5. And then the area of the first, 36, and the area of the second is the one we do not know. Depends on what you want to do. Would you like to reduce? That's fine. I would leave it like a fraction in this case because 36 is in the numerator. Just letting you know. If it were in the denominator, we'd have a different story. But we can reduce. What does it reduce to? 2. I'm going to put 2 over 1. Just in this case, because the 36 is in the numerator, not the denominator. What is 2 squared? 4. And then 1 squared is still 1. If we hadn't made it a fraction and we just left 4, this is more complicated to solve. Do you see what I'm saying? Because the number is in the numerator and a is in the denominator. That's why I like 1 still in the bottom. We're going to cross multiply, so you get 4a equals 36. So then what is the area? 9 centimeters squared. Perfect. Again, make sure your answers make sense. My shape is smaller, correct? So my area should be smaller. It only makes sense. I would like you to try this on your whiteboard. Bless you. Sorry, I wasn't aggressive as this should have sounded. So, are these two from the same shape? Oh, they are. You know, that's great. You did a good job. Are these two from the same shape? Yes, you reduced. Okay. That's good. Okay. I'll stop asking. That's good. That's good. 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 So, first of all, so 7 is PQT, right? Isn't that the area you don't know? PQT. So these two aren't from the same triangle, and these two aren't from the same triangle. So you're gonna just look them up. So you did not square it. So you gotta make sure you square. That's good. That's good. Good. Ready with the answer? You just write meter squared. How to check your math score? Oh, I'm sorry. This is not a 5, 9. That's a square. It definitely looks like a 5 and a 9. I'm sorry. It had like 6 numbers. Well, it looked like it was not. Okay. So, the main reason I picked this one is because you're finding the area of PQT, which is this one. So you got to be careful when you pick side 1 over side 2 equals area 1 over area 2. Straight across, the main thing I was looking for is that straight across came from the same shape. So what side did most of you pick first? 10, which comes from SRT or RST. Do you know the area of that one? Yeah, it's 75. Whereas this one is 14. Do you know the area of that one? You don't. So just make sure you have that. You can either reduce and square and all that stuff, but you end up with 147 meters squared. That's good.